Well, hello, ladies and gentlemen of the 3C class. We're talking about graphing, stretches, and squishes today. Squishes is not actually a technical math term. The technical math term there is called compressions, but I like squishes a little bit better. Our goal today, I know how to change the equation of a parabola so that the shape of the parabola is transformed and I can graph this new parabola. Okay, so we are going to change this just slightly. So I'm going to show you this slight change. Let me get my pen down here. Here's the slight change I'm going to do. I'm going to add a number in front of 2x squared. Now we're going to call this number the a value. And here's why we're going to call this a value. It's because the general form of the parabola is like this. Y equals a x minus h squared plus k. Now this looks the same as we did the last class. Remember, whatever we put in here and here is the vertex. Well, now we've just got this other number hanging around out front and we want to see what it does. So basically here's what it does. It's going to multiply everything that was x squared before by 2. So let's look at this table of values. This was our x squared before, so negative 3 squared was 9. Now we're going to multiply that by 2, and it becomes 18. Because we put this 2 in front of it, this is an understood multiplication in here. That means multiply. So we're going to multiply all of these things in here by 2. Ooh, multiply 0 by 2 even, which doesn't do anything, so it's kind of useless to multiply that by 2. But we're going to do it. And so what we end up getting with is 8, 2, 0, 8. Whoops, that's not an 8. Glad you caught me on that one there. I know, I heard you guys screaming at it. That's not an 8, Mrs. Caldwell. There we go. There's my 2. There's my 8. And then 9 times 2 is 18. So how does this change the look of the parabola? Well, these x's are all staying the same. So I'm still going 1 over from the parabola, except that now instead of going, see this one going 1 over was this one here and this one here. When I go over 1, I used to go up 1. So that was this part here. When I went over 1, I went up 1. Now, look what I have to do. I have to go up 2. So I'm going to actually do that. Let's take, oops, that's not what I wanted. Let's take our pen. And when I move over 2 spaces, or 1 space from the parabola, that brings us to this 1 right here, I have to go up 2 instead of 1. So I have to go up to there. And it doesn't matter where we are in here, we have to go up to there. Okay, now before, when I moved over 2 spaces, we went up 4. Now look what we're going to do. We're going to go up 8. So if I get my pen back here again, when I go over 2, it was 4, now it's 8. So it has to be up here, and it's the same on both sides of the parabola. Now when I move over 3, looky here, when I move over 3, it says I have to go up 18. I don't have 18 spaces there, so I think I'm done. I just have to draw on my new parabola. Now notice, 0 didn't change. It's still sitting right down here, so that vertex didn't go anywhere. And I'm going to draw on my parabola. Look, it's gotten stretched. It's stretched itself out because all those y values got bigger. Now that is the worst looking parabola I think I've ever done. Let's try that side again. Going down, 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 down. There we go. That's a little bit better. Okay, so there's my new parabola. It's changed shape a little bit. Has the same vertex. It's just these things have gotten shifted in. It's like all of these y values get stretched up. It's like I put a tack right here on an elastic, and then I pulled and I stretched it up. And that's actually what has happened. We call that a stretch. Now, so what does that mean in general? Well, notice that for each horizontal distance you move away from the vertex, you move up that same distance squared, then multiplied by the a value. We just multiplied everything by that too. And this happens whether you move left or right. So over 1 unit is still up 1 squared, which is 1, but then we have to times that by whatever that a value was out front. Over 2 was up 2 squared, which is 4. Okay, remember we're still looking at that squared. I'm going to highlight that. Squared. We still have to have that squared. But now, after I square it, I have to times it by whatever that number is out front. Over 3 would be up 9. Now I'm going to times that by whatever out front. Over 4 up 16, but now I times that by whatever's up front. Are you tired of me saying that yet? Over 5 would be up 5 squared, which is 25, but then I have to times that by whatever's out front. That A value is the front value. And now n, we go dot 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 over n units. We still have to square whatever unit that is and then multiply it by that A value that's out front. So let's have a look at a few examples. These are similar to the last one because I'm going to be honest with you, I was a little bit lazy, so I just copied this and then put in a few different numbers here. So this says state the vertex of each parabola and then graph it using the pattern we discovered. Mark on the axis of symmetry for each. Okay. I may not actually mark on the axis of symmetry on all of them, but we'll have a look. So the vertex is the same as it was before. We're going to look here and we're going to look here. So the vertex in this one is, remember, we've got to change that sign. It's the opposite sign. Opposite sign. So it's -1, -10. So there is my vertex, and I'm going to put that on there. -1, -10. It's right down here. Except instead of now going over 1, up 1, remember we went over 1, up 1, over 2, up 4, over 3, up 9. That's what we used to do, but now we have to multiply. Notice I made really teeny tiny dots. That's because those aren't the dots I want. I have to go up 3 times what I used to do. So instead of going up 1, I'm going to go up 1 times 3. So it gets here, and on the other side here. And instead of going up 4, I'm going to go up 4 times 3, which is 12 spaces, which would take us here, and then 2 more here, and over the other side here. And instead of going over 3 up 9, now I have to take that 9, what I used to do, and multiply it by 3, which is 27, and there's no way that's fitting on there. So those points are all I've got, and I draw in my long, skinny, stretched up parabola. Now have a look at this one here. What's our vertex on this one? Well, here, and there's nothing out in the back, so this looks like it's 2, because we have to take the opposite sign, and since there's nothing out back, we put a big 0. So 2, 0 is right here. Now remember, when we get our shape of a parabola, instead of going over 1, up 1, I have to take that up direction, that up 1, and multiply it by half. So 1 times a half, or half of 1, is a half. So I'm going to go over 1, up a half. Now, I used to go over 2, up 2 squared, which was 4, which was way up here. Not going to do that now. Nope, not going to do it. We're going to go up half that distance, which is 2. Now, over 3 was up 9. Again, we're not going all the way up to 9 because this A value, that thing here, tells me I only have to do half of what I'm supposed to do according to the shape of the parabola. So I have to go up half of 9, which is 4 and a half. Now I think I can fit another one in here. Over 4, 1, 2, 3, 4, would have been up 16. 4 squared is 4 times 4 is 16. But now we only do half of 16. So I go up 8. 1, 2, 3, 4, 5, 6, 7, 8 would be right here. And I'm going to do it on the other side as well, which is going to give us right there. And now I got this nice parabola shape. I'm going to join the dots the best that I can. And there we go. Now notice the shape of the parabola has changed. This one's a little bit wider than we're used to. This one's a little bit narrower than we're used to. I call this one a squish because it looks like somebody has stepped on the parabola and made it a little bit fatter. And this one I call a stretch because they've stretched it up, made it tall and skinny. Okay, now going over here, is this one going to be a stretch or is it going to be a squish? Well, judging from what we have up here, this new one looks a whole lot more like this than it does like this. Remember this number, we halved it. Now we're going to take a third of it, so that's going to squish it even more. Where here I was timesing it by 3, so I was making it bigger. So I was making it tall and thin. So let's have a look at this one here. We're going to go to plus 5. 1, 2, 3, 4, 5. And that's it, because there's no brackets. So remember, when there's no brackets, the first value of the vertex is 0, and then we get the 5 on the end. So we have 0 and 5. Now we're going to go over 1, and instead of going up 1, we go up a third of 1, which is just a third. It's right here. And when we go over 2, well, I'm not even going to go over 2, because over 2 would be up 4, and a third of 4 is 1 and a third, which is hard to put on there. I'm going to do 3, over 3, 1, 2, 3. Over 3 was up 9. So now I have to go up a third of 9, which is over 3, and up 3, and that will actually happen. Every time we have a denominator here, we go over and up the same amount. We'll go over 3, up 3, whatever that denominator is. And that's that for that. Okay, now hopefully you're getting the hang of it, and there's 3 more here that I want you to finish on your own, where you're multiplying what we, actually maybe we'll do one more. Do one more here. Here's our h and our k value, so the vertex is -6, -4. And we're going to go to -6, -4 for our vertex. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's our -6, -4 for the vertex. Now this says 2 times what we used to do. Remember, it was over 1, up 1 squared. Now it has to be up 1 squared, which is 1, and then times by 2, that front number. Over 2 was up 4. Now I have to double that because of that number out front. Whoop. Whoa, that's doing something weird. Let's get rid of that. Okay, up 4. And now it has to be up 8. So right here. And I don't think we can put another one on, so we'll leave it like that. Draw a nice smooth parabola. Put little arrowheads at the end so we know it keeps going on forever. Now I'd like you to try these other 2 and flag somebody over in class to see if you've done them right. But I want to go on and ask a different question and say, what happens if the a value is negative? Well, I'm going to pull up the Desmos calculator to try and answer that question. So here on Desmos we have a parabola graphed. Hopefully you can see that this matches here. We've got this going backwards 2 spaces and up 3 spaces according to this backwards 2, up 3. Okay, there's our vertex, backwards 2, up 3. And it's been stretched by 3. So we've got this, when we go over 1 from the vertex, we should go up 3. 1, 2, 3. And we do. It's right there at -1, +6. Okay. So there's our parabola. Now what happens if that is negative? Do you think something's going to happen to the vertex? Is this vertex going to move anywhere? Well, I won't keep you in suspense any longer. I'm going to stick a negative in front of there. Whoa, look, the vertex didn't change. It just went down. Ooh, that's fun. Negative, positive, negative, positive, negative, positive, negative. Okay, a one with a negative there is an upside down parabola. We say it opens down. So, what happens when the a value is negative? The parabola goes down. Okay, so the parabola goes down. Let's try these ones. Graph the following parabolas. Pay attention to the direction of opening. So, again, we're going to get the vertex out of here, and that's going to be 2 and 10. So we go 2 and 10. It's way, way, way up here. And now over 1 would have been down 1 since it's upside down. But it's also got this stretch here. So instead of going down 1, I go down 1 times 3. 1, 2, 3. Over 2 would have been down 4 if this wasn't there. So now it has to go down 4 times 3. So we go down 4 times, that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a long, skinny parabola. There's sometimes the hard ones to draw. And I don't think I'm going to get the next one on there, so I'm going to draw out this long, skinny parabola. and it's upside down. Okay, now this says pay attention to the direction of opening. Now, is this one down? That is no. This one is going to open up because that is not negative. There's no negative. So our vertex, let's take our vertex again. It's going to be -1, -4. So back 1, up 4. Oh, down 4, sorry. 1, 2, 3, 4. And this one goes up. So over 1 would have been up 1 with yesterday's work, but now we have to only do half of that, so up a half. Over 2 with yesterday's work would have been up 4, but now we only do half of that, so we go up 2. Over 3 would be up 9, but we only do half of that, so it's up 4.5. And I can fit another one on there. Over 4, 1, 2, 3, 4, would have been up 4 squared, which is 16, but now I only do half of 16, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. There and there. And that's enough. We might even be able to fit one more on there, but we're not going to. So that one opens up. Do we have another one opening down? Nope, we sure do. Let's have a look at these two. They both open down. Look at that. These mean down, down, down. Down, down, down. There's negatives out front, so they open down. These two also don't move left or right because they don't have brackets. So the vertexes are at 0 and 4, and this one is at 0 and -4. So let's try these two, and then I'll leave the last ones for you to finish off too. So this one's 0 and 4 will be right here. It opens down, down, down. So over 1 would have been down 1, but now we got that a value. We have to do a third of 1, which is 1/3. Over 2 used to be down. I'm not going to do that. Thirds are yucky to work with. So just remember the over 3, down 3 when you're working with thirds. 1, 2, 3, 1, 2, 3. And that's probably good enough. We'll get a nice smooth parabola there. That's good enough. Whoops. Lost my pen. There we go. That's good. Okay, now this one over here again opens down, down, down. So we're going to go to -0, -4. 1, 2, 3, 4. And over 1 used to be down 1. Now I have to do 2 times that, so it's down 2. And over 2 would have been down, down, down 4. Remember, 2 squared, 4. Now it's going to be down 8, and I really have no room for that, so I'm just going to try and put this on here the best I can, this nice skinny parabola. That's it, folks. That's all she wrote. Now there's 2 more there for you to do, and make sure that you check with a classmate or check with me while I'm when you see me in class, and or whatever teacher may be teaching you this. And we will talk to you later. That's the end of this video.